Before we get into a new chapter, let's try to review again what we have learned about the implicit differentiation. So this is one of the problems that you have on your homework. In biophysics, the equation is stated like this, and it's called the fundamental equations of muscle contractions. The L represents the load, and the V is the velocity of the shortening of muscle fibers for a muscle. And we are asked to find dl over dv using the implicit differentiations. So notice that this is dl over dv, is not dv over dl. So it means that the rate of the load changing to the velocity changing. Okay, so I'll put it again. L plus with m, the m is a constant, times with v plus with n equal with k. So I'll use distributive property, so that will be L times with v plus with n times with L plus with m times with v added again with m times with n equal with k. Notice also that m, n, and k are constants. So if we apply dlv over dv plus with dnl over dv plus with dmv over dv plus with dmn over dv equal with dk over dv. What will be 0 will be this part. Okay, again, why? Because m, n, and k are constants. So let's just examine this one, dl v over dv. So we'll have it's like what we have discussed. This is the variable L times with v. So we treat it like using a product rule. So in that case, it will be v times with dl over dv. Okay, first equations times with the derivative of the second equations added with the L times with dv over dv. Okay, so this is the result of the first term, and then over here I can put it as a n times with dl over dv added with n, because n is a constant, times with dl over dv added with m times with dv over dv. But notice that dv over dv will be equal to 1, so I'll just put it times with 1 over here, added with 0 equal with 0, so this will be equal with 0. And then let's open the parentheses. For this case, dv over dv, that will be equal to 1. Okay, so I want you to notice this, and then we can just rearrange again. This will be v times with dl over dv added with l plus with n dl over dv plus with m equal with 0. If we want to apply it better, so it becomes dl over dv. So notice what we'll have. We need to subtract L and M on both sides. So I'll put it over here. So it will be subtract with L, subtract with M on both sides, and then divide by, look, we have V added with N, dl dv. So divide by V plus with N, and we got our equations for this one. Okay, let's try one more before we get into our real topic, which is the related rates. So let's say we have x squared minus 2xy minus y squared equal with 7, and then we are given dy over dt equal with -1 when x equal with 2 and y equal with -1. find dx over dt. So now we have like a 3 variable. This is respect to time, and we can just treat it like this. I'll put it again: x squared minus 2xy minus with y squared equal with 7, and then I'll put it as a dx squared over dt. Everything is respect to time, minus with 2 times with dxy over dt, minus with dy squared over dt equal with d7 over dt. For we can simplify several things over here. This will be equal with 0, and then we'll have over here dx squared over dt. Put it this way using chain rule. So we'll have dx squared over dx, right, times with dx over dt. In that way you'll be able to cross this one and cross this one, and then you'll get back to dx squared over dt. But that's not our goal, to have the chain rule. The goal is to find the derivative. Minus with 2 times with, again, we have dxy over dt. This is a multiplications of functions, so it will be x times with dy over dt, and then added with y times with dx over dt. Subtract with dy squared over dy times with dy over dt equal with 0. So then for over here, the x squared over dx will get 2x times with dx over dt, minus with, I'll just open the parenthesis, so it will be negative 2x dy over dt minus 2y dx over dt, and then negative dy squared over dy, that will be 2y times with dy over dt equal with 0. Okay, now we are given the informations that x equal with 2, y equal with negative 1, and then dy over dt equal with negative 1. So we'll just put everything into over here. Yeah, so I'll just begin to have it like the x is 2, dx over dt is what we want to know. This is 2, and then we also get the y is negative 1. This is negative 1. dy over dt is negative 1 also. Okay, this is also negative 1. Okay, so then I'll put it again: 2 times with dx over dt minus with 2, and then minus with 2 dx over dt minus 2, okay, equal with 0. Yeah, so this, the blue one, is the variable that we already know. So we can put it as a 4 dy over dt, and then a plus with 4, right, and then plus 2 dx over dt, and then minus with 2 equal with 0. Then we'll have 4 minus 2 will be 2, right, and then put it over here, that will be equal with, so we'll just have a negative equal to negative 2 on the right side, and then we'll have 4 dy over dt added with 2 dy, sorry, this is supposed to be dx over here. Yeah, I forgot, this is dx. Let me put it dx, this dx. Okay, so 4 dx over dt, this 2 dx over dt, that will be 6 dx over dt, and then dx over dt, you have 6 over here divided by 6, so 6 move over here, and then we'll get negative 1 over 3. That's how we get our result. Now if you understand this, that you can put it to to the rate of change respect to time, okay, which is the third variable, then we are ready for the related rates. So the objective of related rates is that you'll be able to find the derivative of an equation with respect to the various variables, and you'll be able to solve the various rates of change applications. Let's try to examine this problem. So related rates and business. Suppose that for a company manufacturing flash drives, the cost, revenue, and profit functions are given as below. Yeah, where the production's output in 1 week is X flash drives. If production is increasing at the rate of 500 flash drives per week. So let's stop to this one. The production is increasing at the rate 500 flash drives per week. So we can put it as the information's dx over dt equal with 500 flash drives per week. And we want to know when the production is 6,000 flash drives, find the rate of increase of the cost. So when the x is 6,000, what is the rate of the cost? Is it increasing or is it decreasing? Okay, so let's try it for A. Then it will be, I'll write it again, C equal with 5,000 plus with 2x, and then now we'll apply the rate dc over dt equal with d5000 over dt plus with 2 times with dx over dt. I assume that you already know how we do this, 2 dx over dt using a basic differentiation property. And then again dc over dt, d5000 is a constant, so it will be 0, plus with 2 times with dx over dt. We already get dx over dt, which is 500, so just put it over here, and then we'll get dc over dt is 1000. So it means that by the increasing of the production's 500 flash drives per week, we'll have a cost increasing also by $1,000 per week. Okay, let's do B. So I'll just put it again, R equal with 10x minus with 0.001 x squared. So again, we want to find the rate of the revenue for 1 week. So that will be 10 dx over dt, okay, minus with 0.001 dx squared over dt, and then dr over dt equal with 10 times with, again, dx over dt, it's given over here, so we'll put it 500, subtract with 0.001. Now dx squared over dt, we'll use the chain rule, dx squared over dx times with dx over dt. Yeah, and then dr over dt will have 10 times with 500, that will be 5,000. This is, by the way, 500. Okay, that's better. Okay, subtract with 0.001 times with, over here, that will be 2x times with dx over dt, which is 500. Now we are also given that the x happen will be 6,000, so that will be 5,000 minus with 0.001 times with 2 times with 6,000, yeah, from the given information, times with 500, and that will be equal to eventually negative 1,000. So by the increasing of, the rate of 500 flash drives per week, then the revenue will decrease by $1,000 per week. And what about the profit? So the profit, C, is P equal with R minus with C. We can just put it like this: dP over dt equal with dr over dt minus with dc over dt, and then we'll get the dr is negative 1000, and then dc is 1000, so we'll get negative 2000. It means that the profit is decreasing at the rate of $2,000 per week. I noticed that I should put week over here, yeah, and I should put the dollar, yeah, dollar sign. Okay, let's try another one. Let's have this. A 26-foot ladder is placed against a wall, so it's just like this. If the bottom of the ladder is moving away from the wall at 3 feet per second, so this one, let's say the ladder is moving away, I mean it slip away, at what rate is the top moving down when the top of the ladder is 24 feet above the ground? So I'll try to redraw again over here, yeah, and let's put what we know. It says that the ladder is moving away from the wall at 3 feet per second. So if this is a x, okay, it means that dx over dt is, so it means that it's increasing by 3 feet per second. This is positive, okay, because it's increasing toward that directions. If you have the information, if the let's say if the ladder is slipping away and then it decrease, if the top of the ladder is slipping down, so you'll have negative. You can see it on the example of problem 1, okay, then it will be negative. But this one, the x is increasing by 3 feet per second. At what rate is the top moving down when the top of the ladder is 24 feet above the ground? So we'll also have that over here, this is 24 feet, and also given to us that the ladder is 26 feet. So the ladder will not change its shape or size. We'll just assume that this is 26 all the time. And then what we already know from Pythagorean theorem is that if you have a x squared plus y squared equal with, in this case, like x squared plus with y squared equal with the hypotenuse square, and that will be equal with 26 square. The x will change, the y will change, right? So we can put it like this: dx squared over dt plus with dy squared over dt equal with d26 squared over dt. Now, what will be the derivative? So it will be using a chain rule, dx squared over dx times with, why I put it over here, yeah, it's okay. Anyway, we'll have dy squared over dy times with dy over dt equal with, now d26 squared over dt, it's a constant, so it will be 0 over here, and then we'll have 2x times with dx over dt. Now I'm having a trouble. Okay, dy 2y times with dy over dt equal with 0. Okay, then let's try to put several things in. We have, what do we have? We have the y, which is 24. We have dx over dt, which is 3 over here. I'll just move this one over here, so you can see it better. Okay, just want to show you that everything is the same. Okay, I'm going to erase this one. Like what I say, we know the x is okay, we don't know what is the x, but we can find it. We know the y is 24, so 2 times with 24 dy over dt is what we're looking for. Dx over dt is 3 feet, so we can put it over here, 3 feet. But what is the x? How to get the x? When the y is 24, can we find the x? Yes, so we'll just put it over here, x squared plus with 24 square equal with 26 square, and then we'll get x square equal with 26 square minus with 24 square, and then x equal with square root of 26 square minus with 24 square, and then eventually we'll get that it's equal with 10. Okay, so I'll put it over here, 2 times with 10 times with 3, and we are looking for dy over dt equal with 0. So this will be 60 added with 48 dy over dt equal with 0. And then yeah, just put it like this, dy over dt equal with, so subtract with 60 and you divide by 48, and then you'll get negative 10 over 8, or it's equal with negative 1.25, which means that the ladder will slip down, okay, when the x is increasing or moving away from the wall at 3 feet per second. It will slip down by 1.25 feet per second. Okay, so that's how we get our answer.